Hello everyone, myself Sneha Katale, and today we would be continuing our database management system topic, and we'll be discussing about data abstraction. Um, so data abstraction is basically hiding implementation details and showing only the relevant information to the users. Um, this helps in making the system m- more simplified for the user interaction, and this is it important because uh, for retrieving the data efficiently and for the system to be usable, for designing the complex data structures by designing a system which involves use of complex data structures, uh, because we need efficiency, uh, the system becomes complex, and for user to interact with such kind of system becomes difficult. So making the user interaction simplified, making it user friendly, but still maintaining the efficiency. So for that we need data abstraction. So it occurs in three levels: physical, logical, and view level. So view level, these are the three levels of data abstraction. So in view level, it is the basic level where only the data which is relevant to the user, only the part of what is stored in the database is um, accessible to the user. And there are different types of view levels, different types of what is stored in the database is presented at different view levels. So only a relevant part of the database is shown to the user, particular user. Then that part may not be relevant to that particular user. So another part of the database which is relevant to another user may be shown to the other another user of the database at the view level. There are different views with different relevant information shown to the different people. At logical level, it is the level where what is stored in the database is shown to the user. It is the level where database administrators work, and yeah, basically what is stored in the database. In physical level, how the database is stored and all the complex data structures which are involved in making the data set is visible to the user at this physical level. Mostly system designers have access to this physical level of data abstraction. So that's how it is. Next, database terminologies. So first of all, we need to understand what schema is. Schema is basically overall design of the database. So how the database is constructed, what the design is, its schema. Data independence. Basically, data independence is like um, for at a particular for a particular user for a particular in one database system at one level of database system, uh, the database schema, like the design of the database, can be changed without affecting another level of database system. That is data independence. So this helps in security, keeping the data separated from all the programs. So we don't have to give access to all the programs that are running on a particular system, right? So in data independence, that basically means that we don't have to give access to of the data to our entire system if we're working on one system. And these two database system levels can change or make changes in the database without requiring to affect each other's levels. That's data independence. Instance or database state or snapshot. That is at a particular instance, that is at a particular moment of time, what information is stored in the database, what data is there in the database is known as the instance of a database. DBMS architecture. So there are three types of DBMS architecture: one tier, two tier, and three tier architectures. So in one tier architecture, how database is like, what are the different stages, or what how many stages are involved in the database. That's the DBMS architecture. So in one tier architecture, everything is present on a single system, a single machine. So client, server, and database, all of them are present on a single system. So this is also known as single user system or local database system. So this is like everything is present on one machine. So it is also centralized system. For example, when we set up an SQL server on a local machine and use that database, that's one tier architecture. So the thing is, in one tier architecture, it's easier to communicate with the server, like information retrieval, no security issues because we don't have to give access to any other user, right? But the problem arises as we need to communicate, like data communication, then it would be difficult to give access and show it to the other people. So for the two-tier and three-tier architectures come. So why three-tier came? Because of the limitations of the two-tier, we will discuss later. So this is what it is about centralized system and single user central system and single user system. This is how a centralized computer system looks, and this is a one-tier architecture. Okay, so two-tier architecture, it is also known as client server architecture because here client and server side are on different systems, right? So here APIs like ODBC and JDBC are used in this interaction. So application programming interfaces are used to connect these two sides like client and server sides. So what happens is client establishes a communication through calling the APIs or through the various API protocols to the server side. It sends data to establish a connection to with the server side, okay? And then it also sends the data for the processing by the client by the server. So client establishes the connection, provides the data on which the processing needs to be taken place. So then server processes the query, and transaction management functionalities are handled by the server side. And then it sends the data, processed data, or whatever the results are expected by the client back to the client. So that's how it works basically. So on server side we have database, and on client side we have applications or programs or user interfaces, right? That's how it happens. So it is easier to maintain and understand. It is compatible with existing system, how existing systems are working, the applications that we use in our day-to-day lives, like Spotify, YouTube, where server client server side, that is two-tier architecture is used. So that's how it happens. And the problem with so that's how the general structure of client server system is there. So many clients are connected to the same server through a network, which is communication protocol. That is a connection which is established by the client side. Um, the problem is if there is a large number of users connecting to the same server, then issues might arise, server load increases, and hence the efficiency reduces and the latency increases. That is the response time by the server, the communication slows down. So for that, three-tier architecture came into picture where there is another layer between client and server side. So client does not directly communicate with the server. Instead, there is an application server which is in the middle layer of the client and server side, which communicates with the database. And after the server processes all the queries and transaction management functionalities, the data is sent to the application layer, right? It interacts with the application layer and application server, and then the application server is in contact with the client server. So It acts as a medium for exchange of process data between server and client. So in case we have a lot of users, like very in case of very large application where there is large number of users, server load needs to be reduced, and hence connections are established between client and application server, which in further communication with the server with the database, right? So here also another limitation of client server, that is 2 architecture, is overcome, which is security. So the thing is, as we have to establish in case of client server architecture, we have to establish communication at every uh, every point of time. Like once a connection is established, it doesn't remain till all the data is processed by the server. No, one, one connection, one query resolved. But in case of 3-tier architecture, just one communication is essential and all data processing takes place. And client and server are not directly connected with each other, and hence unauthorized data access is reduced, data integrity is maintained, data corruption can be avoided or removed, and scalability is enhanced as distributed deployment of application server takes place. So individual connections are not essential in between client and server. That's what I said. So in the next video, we will discuss about server system architecture. So that's all for today. And if you have any questions, let me know. I'll do my best to answer them. Thank you so much for listening to me.